this as ux minus v uy equal to 0, and this v is ux equal to 0. Now, if we square and add them, so what we get? Squaring and adding. So we obtain that the 0 is u square v square and the ux square uy square. So this is mod fz square, and this is a prime z square. So this is k square, and this, since k is non-zero, so this implies this derivative square equal to 0, since this k is non-zero. Okay, so we see that this a prime z 0, that is a prime z 0. So here f is constant. Okay. Okay. And okay, so this 3 question is solved. Okay, so another question is, show that there are complex number z satisfying this equation, modulus z minus a plus z plus a is 2 into mod c, if and only if this a less than equal to mod c. Okay, this is part 1. And part 2 is, if this condition is satisfied, then find max of mod z and minimum of mod z. Okay, so anyone has any suggestion how to solve this, the part 1? No. Okay.
Triangular inequality.
Yeah.
So can we use triangular?
Triangle inequality. Using triangle inequality. So what we get? So it is easy to see that this 2 into this mod a can be written as this z minus a. This we can write, and here by triangle inequality we can write this. And since this is 2 into mod c, okay, so this implies this mod a less than equal to mod c. This is one implication. And the second implication, so if this a is 0, if a is 0, then it is true. Okay, we have to show that there are complex number satisfies this equation. So, okay, so let a not equal to 0, and we consider the z, the complex number, as a by mod a into mod c. Now a simple trick like this. So 2 into mod c, this can be written as mod c upon mod a minus 1 plus mod a into this mod c upon mod a plus 1. Now this can be written as this plus this. Okay, so this is what it is. Or we can alternatively the case a not equal to 0, then we can consider a number b, this mod c square by mod a square minus 1, and if we choose this z is equal to this ab into I, then we can show that z minus a plus z plus a into mod c. Okay. The second part, we have to find the maximum minimum. Okay, so we can start. For maximum minimum, we have to find the bound of mod z. Okay, so we can start. So 2 into mod z. So again, we can write this. So again, by triangle inequality, we can write this is z plus a plus z minus a. So this is 2 into mod c is given. So this implies this mod z less than equal to mod c. Okay, this is number 1. On the other hand, this modulus z minus a plus z plus a. So this we know this is 2 into mod c, and since mod c greater than equal to mod a, so you can write this is 2 into mod a. So if we rearrange in this way, so 2a less than equal to modulus z minus a, z plus a, and apply triangle inequality in each of the modulus. So this is mod z, mod a. So this is mod z, mod a. So this equal 2 into mod z plus 2 into mod a. So this shows that mod 2 into mod z, this is greater than equal to 0. Therefore, mod z greater than equal to 0. So if we combine this 1 and 2, what we get? So this is mod z less than equal to mod c. So it shows that the maximum of mod z is mod c, and this minimum of mod z is 0. Okay. Okay. So another question is, let this argument z is mapping from the c difference, this r greater than equal to 0 to minus pi to pi. Okay. Be the usual argument. Usual argument function. Okay. So here, say here this r greater than equal to 0 denotes set of all non-negative real numbers. Okay, the non-negative real numbers. Okay. Okay. The question is, prove that the function f of z, this e power minus argument z into cos of log mod z plus I sine log mod z is holomorphic. Okay. And the next question is, what is this f prime z? Okay, anyone has any suggestion? So we know that,
Sir, it is positive real axis or negative real axis, sir?
yeah,
Hello.
yeah, yes, yes. The notation are greater than or equal to 0 or less than or equal to 0. That's it, na? Am I audible?
Yes, sir. On defining
Yes, sir.
argument, it is, we are deleting positive real axis. Negative real axis.
Yeah. Non-negative.
No, sir. On
Non-negative.
defining that argument function, so we remove negative real axis. Yes, sir.
Yeah. So this is negative real axis, right? So the question is, do you have the question? Hello?
Question, it is r less than or equal to 0. But
R
that
less
is
than or
written
equal
as non-negative. Yeah. In the question that is written as non-negative, but when we are doing from minus negative real axis.
Yeah, so what will be the correct one? Because in the end it is holomorphic.
R less than or equal to 0, sir.
Yeah.
R less than or equal to 0, sir. That one in that C minus R less equals 0.
Okay, so I should rewrite this R less than equal to 0. So here also R less than equal to 0. So it is set up all negative real numbers, right? Okay. So we know that. Okay, we will use this log z ln mod z plus I into argument z. So with that, f of z, so this is argument z cos ln mod z plus I sine ln mod z. Okay, so this can be written as this argument z into so this is I ln mod z, right? So you can write this is ln mod z plus I into argument z. So this can be written as I log z. Okay, so log z is holomorphic, right? So this e power I log z, since log z is holomorphic, this implies f of z and e power z. So it's a composition. The f of z is also. Now, what is the derivative? Now, f prime z. Okay, so the composition formula, like let if we write gz is I log z, then this f of z can be written as this gz. So therefore, this f prime z is e prime gz into g prime z. So we see that this is I log z into I by z. So I by z e power log z. So this is the derivative. Okay. So is it okay?
Yes, sir.
Okay. Okay. So okay, now I'm going to next question. So it is question number 4 in the question. So part A. So let Z and W belongs to C such that Z omega bar not equal to 1. This much is given. Okay, so then prove that if so, did you solve this question? Anyone? Then modulus this z divided by 1 minus z, this is less than 1. Okay, this is, and moreover, if the equality holds, like 1 minus z w bar, so this is if and only if mod z1 or mod w1. So anyone have any suggestion from anyone? Anyone solve this question? No. Okay, so okay, it is enough to show. It is enough to show that this w minus z, this is less than 1 minus zw bar. So am I correct? So that means if we show that this less than 1 minus zw bar square, then we are done. Okay. Okay. So what we have, since mod z less than 1, mod w less than 1, so that means mod z square less than 1 and mod w square is also less than 1. Okay. So that means we can write mod z square minus 1, this factorial, mod w square minus 1. This is positive, right? So if we break this, so what we get? Okay, so this can be written as mod z square mod w square, this is less than 1 plus z square w square. Okay. Okay. Now I want to add this quantity, this z omega bar plus z bar omega to both sides of this inequality. So adding this. So this is actually what? 2 into real part of z w. Okay. Yeah. So adding this quantity in the both side, we get what we get, this mod z square mod w square, okay, minus z this z sorry. So this will be z bar w less than 1 plus z square this minus z bar and this quantity. So yeah, so this will give this z minus w square less than 1 minus zw bar, this modulus square. Okay. So this z minus w upon modulus 1 minus zw bar. So this quantity is less than 1. Okay. First part is true. Okay. Second part, we see that this quantity less than 1 when mod w and mod z less than 1. But equality holds. So z minus w by 1 minus zw bar, this is 1. So that means this quantity exactly equal with this quantity. So again, squaring both sides, we get this. So if we simplify, so we will get that mod z square minus 1 into mod w square minus 1. This is equal to 0. Now this shows that z equal to 1 or mod w equal to 1. Okay. Okay. So this is actually part A of the question. Yeah. So part B. So 4B. Part B is the question is, okay. So fix a W inside D. All those C such that it's a unit disk. Okay. And consider the mapping. Okay. Phi W, this is a mapping from D to C. Okay. And defined by, so phi W of Z is defined by this W minus Z upon 1 minus ZW bar. Okay. The question is, prove that phi W has the following property. Phi W has the following property. Okay. Okay. So what are the properties? So number one, so phi is holomorphic. Phi is holomorphic map of this unit disk onto itself. Okay. Number two is phi w interchanges 0 and w. Okay. So number three is phi w is biholomorphism. Okay. Okay. So the solution one, the phi is defined as phi w of z, w minus z by 1 upon 1 minus z w bar. So the first property we have to show is that it's a holomorphic map of D onto itself. So first it is holomorph. Okay, okay. So phi w z is w minus z 1 minus z w bar. Okay, w belongs to the domain D. That means mod w less than 1. Similarly, mod z less than 1. Now this z omega bar cannot be 1, because otherwise, if z omega bar equal to 1, then we see that mod z into mod omega exactly 1. But from this we know that from these two conditions, we know that this should be strictly less than 1. That is mod z into mod omega mod w less than 1. Okay. So this cannot be 1. Therefore, this is so from this we see that this phi w is holomorphic. Okay. Now we have to show that it maps D to D, D onto D. That is phi w of D is equal to D. So by the previous, so that means we have to show that this phi w of z, this is strictly less than 1. Okay. So what is phi w of z here? So it is w minus z upon 1 minus z w bar. So so this is less than 1 by the part A of the question, because mod w less than 1 and mod z less than 1. Okay. So therefore this is less than 1. So this phi of D is D. Okay. So number 2 is I have to show that this phi w interchanges 0 and w. It is easy. So from the definition, that means we have to show that phi w of 0 equal to w, and phi w of w, this is 0. So from the definition of the, okay, so this is our claim, and it is easy to see, because phi w is z, it is w minus z by 1 minus z w bar. So if we put 0 at the place of z, so we see that it is phi w of 0 equal to w. So this condition is yes. Similarly, if we put w in the place of z, it will be 0. So this condition is also satisfied. So we can say that so this interchanges these 2 points. Okay. Okay. So next question is prove that f of z is holomorphic. F of z is holomorphic. That is if and only if this f of z bar whole bar, this function is holomorphic. Okay, and the question is, how are the 2 complex derivatives related? How the how are the 2 complex derivatives are related? Okay. So solution of this problem. So we can calculate. Okay. So since this is if and only if we have to prove, so since f is holomorphic on the sigma, so for all a belongs to sigma and for all r greater than 0, yeah, so for all this there exists this r greater than 0, such that what happened, you can find a disk T close AR. So this is actually all those z in C, such that modulus z minus L less than equal to R. So this will be a subset of okay. And okay, so there exists a sequence. There exists a sequence such that what we get, so this f of z can be written as in the power series expansion. So this an z minus a, this power n. Okay. So this is for all z belongs to this T. Okay. Therefore, now we calculate this f of z bar whole bar. Okay. So we also show that this function also has a power series expansion. Then we are done. So from here we see that this summation, this is n equal to 0 to infinity, this an z bar minus a power n, this is whole bar. Okay. So this the property of the conjugate, so it will be like z bar minus a power n, this individual bar. Now this can be written as this is equal to 0 to infinity this an bar z minus a bar power n. So this shows that when this shows shows that if is holomorphic, okay, if is holomorphic, this is if and only if this f of z bar is holomorphic. Okay, now the second part, how their derivatives are related. Okay, so we will use the definition. So let this g of z is f of z bar whole bar. Okay, now this limit h tends to 0, g of so g dashed z, so g this h minus g of z upon h. Okay, now so if we put the value g of z, so what we get is that f of z bar plus h bar whole bar minus f of z bar whole bar by h. So this is certainly, we can write like f of z bar plus h bar minus f of z bar this whole bar.
There is no, sir, there is no bar on H actually. It's only H, f of z bar plus H.
Yeah, it will be h bar, because if we calculate this one, g of z plus h, so g of z plus h, it will be like z plus h bar whole bar, right? Now this will be f of z bar plus h bar whole bar. Am I right?
Yes, it's okay.
Yeah. So now I can write this limit h tends to 0. So f of z bar plus h bar minus f of z bar divided by this h bar and this whole bar. Okay. Now conjugate is a continuous function, so I can push this limit inside. So this limit h tends to 0, f of this z bar plus h bar minus f of z bar divided by h bar. So h tends to 0, so h bar tends to also 0. So we can write this. So therefore, this whole bar. Okay. Yeah. Now this we can write as a prime of z bar, and this is full bar. So on the left side, so this g dash z is this. What is g dash z? So d dz, gz means f of z bar whole bar. So how they are related? So d dz f of z bar whole bar is okay. So d dz of f of z bar whole bar. So this is the relation. Okay. Yeah. So yeah, another question is, okay, for what values of z, for what values of Z in C is the series, the summation equal to 0 to infinity, is Z upon 1 plus Z power n convergent. Okay, convergent. Next question. In the region that the series does converge, okay, does converge, is it okay? So sorry, so is it absolutely convergent? This is the question. Okay. So the solution is, okay, so this series convergent, okay, the series is convergent if and only if, so this modular Z upon 1 plus Z, this is less than 1. It's like a geometric series. So we have to find the region. That means so this is equivalent to this 1 plus this. Now if we simplify, so if we put Z equal to x plus iy, so we see that this whatever x square plus y square, this is less than x plus 1 2 square plus y square. Okay, so squaring both sides, so we see that it is x plus 1 whole square plus y square, and y square cancel out. After simplify, so this will become x square 2x plus 1. So x square also cancel out. So this is 2x plus 1. That means this ax greater than minus half, right? That means this real z greater than minus half. So the region is, okay, so suppose this is minus half. So this side is, so the region is this side. Okay. Now we'll check that on the boundary whether it is convergent or not. So on the boundary, so let z equal to minus half plus iy. Okay, so this point is on the boundary. Okay. So what we see that this z upon 1 plus z. So what is the value? So half iy, and this is half plus iy. Okay, sorry. So this actually give 1. So this shows that this equal to 0 to infinity z upon 1 plus z is not converse. Okay, on the boundary. Okay. Okay, so for absolutely convergent, you know that on that region, absolutely convergent. Okay. So for that, we have to we have to calculate this series with modulus 1 upon z power n. So I am writing here this n equal to 0 to infinity, this r power n, where this r is modulus z upon 1 plus z. So on that region, so this is less than 1. That means this r is less than 1. So this series is convergent, right? On that region, convergent. So therefore, from this we see that the series is absolutely convergent. Okay.
Sir, how will you check the uniform convergence, sir?
Yeah, uniform convergence. Yeah. So it will be uniformly convergent on that region on a compact subset. On a compact subset, on any compact subset, it will be uniformly convergent. Okay. So okay, I think today it is enough. So next day I'll continue the other problem.
Thank you, Bashir. So, are there any questions on the tutorial? So, if there are no questions, let us thank Dr. Bashir for a very nice tutorial session on the third module. So, we'll meet tomorrow at 5. So, thank you one and all. Suman? Thank you one and all. Yeah.
Thank you, sir. Thank you, sir.
Thank you. Yeah.
Thank you.
Thank you. Bye.
Yes, sir.
Bye.
Bye, sir.